Evaluate the following limit. Okay, well, the wrinkle with this one is there are two signs in this, and the only tool we have for cracking these says that when you have sine something over the same something, that limit evaluates to 1 as theta goes to 0. So we can handle one sine at a time, but sine squared is going to be trouble. So let's pop this thing apart and see if we can handle the pieces. We have limit as x goes to 0. This sine squared 2x I'm going to write as sine 2x times sine 2x. I don't think that'll be too controversial. And underneath we have x. Now, actually, I'm going to change how that's written. Or no, I'll do it in the next line. If we had sine 2x over this x, that's something that we could create an evaluatable limit with. So just to rearrange this a little bit, we have limit as x goes to 0. We can say sine 2x over x. This I intend to turn into a 1. I'm going to have to tweak the denominator, obviously, but this we can use our limit theorem on. And in addition to that, we have this extra piece, sine 2x, which doesn't have an x to be paired up with, so hopefully we can handle that without it being over x. Can we do this part? Ignore the second sign for a moment. We could handle this if only there were a 2 out here, and we've seen that we can arrange that. Let's go multiply our denominator by 2, and we'll multiply our numerator by 2. So this 2 has to be here because these two must match. This 2 is there because when you multiply a denominator by 2, you have to do the same thing to the numerator, and I just put that 2 out of harm's way over here. So if we do that, this entire thing goes to 1 as x becomes very small. Sorry, not 0, 1. And so this limit should be, well, that piece went to 1. The sine of 2x is going to sine 0, which is 0. And then we have the number 2. And, well, just because of this 0, that means the entire limit is going to go to 0 because of that one piece. So a little bit boring as a limit, unfortunately, but the point is we were able to handle this just because we could take this x and associate it with one of the signs and then deal with the others separately. So we can make this theorem work in a lot of cases if only we can make one piece of it behave like sine theta over theta.